is being recorded.
Hello, everyone, and welcome to your tutor check-in welcome to your tutor check-in for the week. This is the tutor check-in for sections 6.1, 6.2, 6.3, and 6.3.1, which is the central limit theorem for sample proportions. I'm going to At this time, I'm going to share my screen and hit over some of the highlights from 6.1 that we have been over already and show you how it connects to the material that you're going to be learning later this week. So, without further ado, let's see if we can start. Would help if I open the file first. Okay, so chapter 6 starts with the normal distribution. You know that this is a bell-shaped curve. You know the properties of the normal distribution. So I'm not going to spend too much time on that. I will spend a little bit of time with this slide just to kind of remind you what we've seen. The normal distribution curve is bell-shaped. The mean, the median, and the mode are all equal and located at the center. The normal distribution curve is unimodal. It has a single mode. It's symmetric about the mean. The curve is continuous. The curve never touches the x-axis. And the total area under the curve is equal to 1. And we also saw the percentages by the empirical rule for areas under the curve, and we learned how to use the calculator to find areas under the curve, which we're going to continue in section 6.2. So that brings us to this formula here. All normally distributed variables x can be transformed into the standard normally distributed variable z by using the formula for the standard score. Z is equal to x minus mu over sigma, okay? Mu is the population mean, sigma is the population standard deviation. And we also saw how we could use normal CDF in the calculator to find areas between two z-scores. Know that for the next couple of sections, 6.2 and 6.3, and afterward in the course, you will be needing two programs. If you are using the TI-84, you have them. If you are not, then you need to go to the announcement where Professor Nickdell gave you calculator programs, and you will need to input the calculator program manually into your calculator, two of them, one for the inverse t distribution, t as in Tom, and one for the chi-square distribution. There are separate videos on each one. If you have any questions, you need any help, let us know and we'll do what we can to assist you. Also, please be sure that you're reading the instructions. We found that with some of the recent homework assignments and some of the quiz grades that people have been losing points because you are not reading the instructions, some of you. So pay attention to the number of decimal places, pay attention to what she asks for, because you will get points taken away And do read her feedback and her comments on the homework. If you have any questions, please ask us. Now, this concept of finding areas under curves and also finding the z-score that corresponds to a given area under the curve is something that we extend in section 6.2. So let me remind you of what those look like, and then let me show you the slides for 6.2. Let me pause this. In section 6.2, which is applying the concept that we learned in 6.1. So let me take you straight to an example here. This is on slide 6. There are, I believe there are 26 slides for this week. So let me take you to this example and let's look at it. Most tests that measure one's intelligence quotient IQ are designed to have a mean of 100 and a standard deviation of 15. It is also known that IQs are normally distributed. In 1916, psychologist Lewis M. Thurman set a guideline of 140 scaled to 136 in today's test for potential genius. Let X be the measure of one's IQ. Sketch the distribution of X, and B, what is the probability that an individual is a potential genius? So when she says sketch, now this is a little bit more extensive than last week because we actually have specific values. And so you need to do a little bit of arithmetic to figure out what these specific values are. The mean always goes in the middle, that's 100. Standard deviation is 15, so you're counting by 15, up from 100 to the right and down from 100 to the left. You want to find the approximate location of 136, which is somewhere over to the right of 130, and we find the z-score by using the formula 136 minus 100 over 15, and we round z-scores to 2 places. Once we find the z-score, that's not my probability. Once I find the z-score, then I do what I did in section 6.1, which is I find the area to the right of it, and we get 0.82, okay? Now there's other ways to use this idea. We have the random ages of CEOs. One thing that does become problematic in some of these sections is we have this. Suppose that the amount of light in lumens emitted by a particular brand of light bulbs is normally distributed with a mean of 450 lumens and a standard deviation of 20 lumens. What percentage of bulbs emit between 425 and 475 lumens? Well, excuse me, I just conveniently left that out, didn't I? So we find 2 z-scores, and then we find the area between the two from negative 1.25 to 1.25. And we do that just like we're used to. I wanted to do one other thing that happens, because this comes up a lot in the homework and can be confusing. So let me read this to you. If the average price of a new home is $245,500, find the maximum and minimum prices of the house that a contractor will need to build to include the middle 90% of the market. Assume that the standard deviation is $1,900 and the variable is normally distributed. Now, this middle 90, most people go, how could it be the middle 90 when 90% is not the middle, obviously? What they mean is that we're going to split the distribution so that 90% is between our divisions. 90% is between our divisions and the rest is in the tails. So in order to split this evenly, you have to think of 90% total, but half of it in each side. So you have to think of 45 because 90 divided by 2 is 45. And so 45 on either side of the mean. And then, of course, 5% in each tail. Why? Because remember, it has to add up to 100. So if 90 is what we're concerned about, 10% is our tail, what we don't want. And so from there, what we have to do is we have to get two z-scores, one smaller one, z1, and one larger one, z2. And we do that in the way that you might expect. But here, I don't know the z-score. So remember, when you don't know the z-score, and we don't know the x, but we really don't know directly what the z-score is. So the z is going to be the inverse norm of the area from negative infinity to the z1 line. And that's going to be, in this case, a negative 1.64. And the area of negative infinity to the z2 line is going to be 1.64 positive. That's going to give us two corresponding z-scores, which we then get down here. And from there, we can solve those to find our x's. Okay. And when we do that, we do our little proportions. We solve our proportions using cross multiplication. We then get that we have our minimum price and our maximum price, and those are the amounts that we need to be within the middle 90%. So we have those numbers here for you, okay? I wanted to make you aware of that. So that's kind of how we're going to use z-scores to work on our applications. Now we have another issue here, because sometimes we don't use individual data, we use sets. So when we have a set of data, we have something in 6.3. So let me show you that at this time, but let me first grab the file.